S. Chand presents educational video lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
So in part 1 we did Taylor and Maclaurin series of fundamental functions. Hello everyone, I am Dr. Seema Thakran. Welcome to S. Chand Academy. If you want to learn engineering mathematics, please refer to the book by S. Chand Publishing. The ebook link is given in the description box below. Now I am just changing the functions, and you see how we write any random function series with the help of Taylor and Maclaurin series. So my first question is, I'll write the Taylor series of 1 plus sin x. First I'll take at x equal to 0, then I'll change the point, and at x equal to 0 it will be Maclaurin series, and if I'll change the point, so 2 points I'm taking 0 and 1. So for the first point, consider the point x equal to 0. So function is first, when you are doing this question, because for fundamental functions derivatives you are habitual of, but for such functions you are not habitual, you don't know what the derivative will be. First you take the derivatives and then you do the calculation part. So first the derivative will be, the log derivative is, this will come in the denominator, and then the derivative of this will be in the numerator. So this is the first derivative, and second derivative quotient rule you will apply. So 1 plus sin x whole square, then 1 plus sin x same, derivative of cos x is minus sin x, then minus cos x as per the formula, and derivative of this. So it will become cos square x. First derivative, second derivative. Now I just simplify it. So 1 minus, and when I'll take out minus common, this is sin square x plus cos square x. And so when we are multiplying it, minus sin x, this will be minus sin x, minus sin x. So minus sin x, and this value is minus sin x minus, I just change here also, by mistake I just left it. So minus sin x, minus take out common, and finally this is the second derivative. Anyhow, for big questions, what we do, we generally go for second derivatives, because because it is anyhow big question, big derivative, or otherwise we can take the third derivative also. The third is the max when we are doing the problems, because after that, because we need only 2-3 terms, then we will get the pattern and we can write the series, the further part. So the derivative of this will be 1 plus sin x whole square, the denominator same, derivative of numerator, that is 0, minus, it is already in minus, so plus, and derivative of this is cos x. So the derivative of this is cos x upon 1 plus sin x whole square. Now I just write the values accordingly. So f0 means log 1 plus 0, log 1 is 0. Then f dash 0 I am writing. F dash 0 will be cos 0 1, sin 0 0, so 0, and it is cos 0 1, so 1. f0 is 0, f dash 0 is 1. Now coming to f double dash 0, this is my f double dash 0. So I have got till now f0 0, f dash 0 as 1, and finally f double dash 0 will be, because this is 0, so f double dash 0 is -1, and finally triple, that is cos 0 1, this is 0, so simply 1 plus 0 1. These are the derivatives for 0. Now I am writing the Taylor series. Taylor series of f at x equal to 0 is given by, okay, for x0 we call it Taylor or Maclaurin, it hardly matters. Both are the same thing. But if it is any other point, then we can't call it Maclaurin. If it is 0, we call it Taylor Maclaurin. It's just very okay. There is no issue. So given by fx equal to f0 plus x f dash 0 x square by 2 factorial and so on. I put up the values which I have calculated. So it is 0 plus x into 1 plus x square by 2 factorial and into double dash is -1 plus x cube by 3 factorial, f triple dash is 1 and so on. So finally it is fx equal to 0 plus x minus x square by 2 factorial plus x cube by. So this is the series of the given function, that is log 1 plus sin x. If the same series I am supposed to write, first what I will do, because I have calculated everything. So Taylor series suppose at x equal to 1 will be Taylor series at x equal to 1. What to do? Fx equal to f1, this time it will not be f0, it will be f1, x minus 1, f dash 1, x minus 1 whole square by 2 factorial, f double dash 1, and then one more term, that is x minus 1 whole cube, f triple dash 1 and so on. So my fx is, I just write down the terms. This was my fx. F dash x was cos x upon 1 plus sin x. What was f double dash and triple? The double was 1 plus minus 1 upon this, and triple was again cos x upon 1 plus sin x whole square. So now at x equal to 1 I have to calculate the series I have already written. So what will be f1? This time it will be log, because sin 1 I can't calculate. So I am writing it as sin 1. Then f dash 1. If in exam you get such questions, what you are allowed to use the calculator, because in degree you can't find the value. Radian value you don't have any formula, you have to use the calculator. So f double dash 1 will be minus 1 upon 1 plus sin 1, and triple will be cos 1. So it means these values you are substituting with the help of the calculator. I am just showing you how you are writing, and these values you can calculate. Just substitute these values here. It means finally what you will do, f dash 1 value from here you will substitute, then f double dash value and triple dash this. You will substitute all these values here. You will get the value of the log of 1 plus sin x at 1. And the whole expression, the complete series will look in x minus 1 whole square by 2 factorial, x minus 1, because these values will be some numbers. Some constant you will get when you will calculate it with the calculator. So this will be a number, some constant, then the complete expression will be in x minus 1 whole cube, x minus 1 you will find everywhere. That is the meaning that you are expressing this series at x equal to 1. So, this is the meaning. So, finally, this way you can write this series. So, now Taylor and Maclaurin series, we have seen that how we are calculating for any particular function, but now I am just taking different problem, and that problem is by using the Taylor series, but how the problem is, what basically the problem is, and the problem says that, show that sin x value lies between x minus x cube by 3 factorial and x minus x cube by 3 factorial plus x5 by 5 factorial. Now, this is the question, and how we solve by Taylor series, and this how we can link up it to Taylor series. Anyhow, with x there is no number, it means you have to take point 0, x equal to 0. One thing is, because we can take our, we can restrict or truncate the series because we are taking remainder tending to 0. To get this value, I'll just write my series till up to 3, that power 3, and to get this value, I'll write up my value to till up to 5. And if I can express sin x in this way, or in this in other way around this way also, so I can say that sin x value lie between these two values, because I can truncate the expression in like as per the condition or as per the situation. So I can truncate the series till x cube and till x5, because in starting I took that it is approaching to the 0, the remainder. So at x equal to 0, function is, so my function is fx is equal to sin x. What will be the derivative? Cos x. Second derivative minus sin x. And third is, because I have to, I have to take it up till fifth I have to write. It will be minus cos x. Then fourth will be sin x. Fifth will be cos x. Because at 0 only I have to consider, what I'll do, I just calculate each and value. So f of 0 will be 0, f double dash 0 is 1, f dash 0 is 1, f double dash 0 is 0, and then third derivative is 1, fourth is 0, and alternatively you can see plus minus sign and 0 we are getting. So, 1 0 1 0 we are getting no negative sign. Here in derivative we are getting the negative sign, minus sin x, then cos x, sin x, then it was minus cos x, I just left this. Anyhow, there will be no problem, but still plus minus sign can make a difference. This is minus sin x, so this was minus cos x, so this is minus sin x and minus cos x. It will be plus and sin x, so derivative will be cos x derivative is minus sin x derivative is minus cos x is sin x, and then this is fine now, sin x cos x. So the change will be here 0 1 0 minus 1 0 and 1. Now it is fine. So we can first I'll write the series till up to power 3. So it means my series I'll open till f0x f dash 0 x square by 2 factorial f double dash 0 plus x cube by 3 factorial f triple dash. It means I have truncated my series to third derivative, till third derivative. Then f0 is 0. Then x, f dash 0 is 1, so x only. Then this second derivative is 0, so I am not writing this term. Then x cube by 3 factorial, and the triple derivative at 0. The triple at 0 is minus 1. This is minus 1. So, minus x cube by 3 factorial, and so I have truncated it, so these values I am not writing. So, this is my sin x truncated value for till cube power. Now, I will write it till 5 power. This is sin x value. This is the same I am expanding till, now this is still up to 3 power, I am expanding it to 5 powers now. So, sin x, it is x cube minus this obviously will be the same, plus the next term, fourth derivative is 0, then fifth derivative will be x5 by 5 factorial. I am writing it in other form. Okay, now two values I have got for sin x after truncation. If this is sin value, this is sin value, obviously the sin value will lie between these two values. This is by Taylor's theorem or Taylor series, you can say. So, this is how we apply our Taylor series and Maclaurin series in different problems. So, this is end of part 2, and in this part we did Taylor and Maclaurin series by taking different functions and different problems. Even we were linking how we can measure a function will lie in like what values, that also we linked up by Taylor and Maclaurin series, or we can say theorem, because when in theorem we approached the remainder tending to 0, we got Taylor and Maclaurin series. If you want to learn engineering mathematics, please refer to the book by S. Chand Publishing. The ebook link is given in the description box below. If you like the video, please do like, share and subscribe S. Chand Academy. Don't forget to press the bell icon for the future updates. Stay connected, stay tuned, keep watching upcoming videos. Thank you.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.